Okay, so we've been talking about functions and functions inside of functions, the inception of functions. So I've got a f of x and a g of x, and where would I start on a problem like this generally? On the inside. And I figure out what g of x is and I put it in there. Okay. So if I said f of x is 1 over x minus 2 and g of x is going to be x squared, would you please try to figure out what f of g of x is? This is called a composition of functions. Composition means what are you made up of? And the composition is these two things put together make a composition. All right, so if I'm going to take g of x, that's the x squared, I put it here. Then that one goes into the f function. So I got to put this one into this one. So then I have 1 over, and I put an empty spot where the x is, and then I drop in the x squared. There we go. That's it. Raise your hand if you had it right. Okay, good. Now what's its domain? Don't say it. Figure it out, and then I'll tell you if you figured it out right. What's its domain? All right, its domain depends on two things. There's two number lines you got to overlap. Which one's the important one, the f function or the g function? The g. All right, so we look at the g function, and, well, that's all reals. That's cool. That's easy. So the domain of g is one of your two of your overlap, and that's all reals. Easy. But then, what's the other one you got to do? The domain of, this is called the composition. The domain of the composition is the other thing you have to do. And that's harder. So I'm looking at this and I'm asking myself, what's this new function's domain? So what's important? That should not be allowed to be what? 0. So then I want to set x squared minus 2 equal to 0. And actually, really, it's not equal to 0 because I don't want it to be 0, because if it is, it'll crash. And then I solve that. That's what probably took you a little bit of time. And some of you probably still haven't done it. Why don't you try that? See if you make the common mistake that everybody makes when you're doing this. And by everybody, I don't mean everybody. Doesn't it seem like the answer is just the square root of 2? There's two things, right? Because when you take the square root here, you have absolute value of x is not equal to root 2, and then you get two answers. X is either root 2, x cannot be root 2, and x cannot be negative root 2. Okay. So how do I graph that? Well, I just pick a spot for root 2, and then I pick a spot for negative root 2. And then I just say it can't be either of those two things. Empty, empty. Filled in, filled in, filled in. Okay? And when all reals overlaps with anything else, the answer is the other thing. So the answer is this one. So you'd say all real numbers where x cannot be negative 2 root 2 and positive root 2. How many of you feel confident on that kind of problem? Okay, good. So next, what if we were given a function and it came out to that? And I know it was an f of g of x question. I know that they made me do this. But you can't figure out what the f function was, and you can't remember what the g function was. It's sort of like you have the answer, but you didn't know what the question was. That's the kind of question that you can get on this unit. It's called, you want to break that down into where it started from. Okay? You want to decompose this. That's what it's called. Just like a body decomposes. You know, when somebody dies and they're laying out in the desert, and eventually their body kind of starts to decompose, and eventually it gets down to be just bones because it takes that longer to decompose. But even the bones will eventually decompose, and it'll eventually they'll just be turned into dirt, okay, or sand or whatever you want to call it. Okay, they'll break down into their elemental parts. That's what we're doing here. We're breaking this down into its like elemental parts. And somebody probably can just tell me the answer for this, right? Before I even tell you. You want to give it a shot? A couple people. What do you think? You want to make f of x equal to what? That works. For some of you, I know I can see some faces that are like, what did she just do? I have no idea what's going on. Other people probably follow it completely. Okay, so does anybody else have a different answer that also would be right? Some of you are like, I don't even understand the first answer. What are you talking about? Yes. Okay, you're thinking f of x could be 1 over x, and then g of x could be x squared minus 1. You're right. It's a lot easier to look at these answers and see if they're right or not. Let's do that. Take a look at this one, and let's see if it really gives me this. If I put the g function into the x function, do you get if I put this in there that it will equal this? It works? You get that? All right. And let's look at this answer over here. I'll circle it in blue because it's kind of got a blue theme going over here. So if I put this one into this one, do you get I would get this answer? All right. So you can see that their answers work, but do you get how to do it? Let me show you a way to do it. Look at this equation right here, this function, I should say. And if you just want to make one part of it get taken out as like my g and let the other part be the x, I can take any part of this I want. I can take any part out. I usually take out a part that has an x in it, but I'm just going to grab this x squared right here and just take it out. If I take that out and call it and say that's the thing I put in from somewhere else, I'm going to say that was g of x. G of x is going to be that thing, x squared. If I take it out of here, it obviously had to have gone into something, an empty spot, right? So what do you put for that? An x. So then what remains is 1 over x minus 1. And here's my g of x, and then here's my f of x. All right, I think some of you are starting to give me that look like you understand it, and some are still a little puzzled. Let's do another one. 1 over x over 2 plus 5. See if you can tell me what f of x and g of x could have been if this one is f of g of x. I'm not going to mess with you on changing it around. It's always just going to be f of g of x. That's my composite function. What were the two parents that made it up in the first place? All right, so there's actually multiple ways you can do this. I'm going to choose to yoink out one part of it and call it my g. Always start with the g function. And I'm going to yoink out that part. I'm going to call it g of x. You say g of x is going to be x over 2. And if I take that out and replace it with just an x, my other function would be f of x is 1 over, and there's just an x in there now, 1 over x plus 5. There we go. Raise your hand if you had it right. Awesome. You already caught on. Let's do one more. It'll look different, but if f of g of x is equal to the square root of x squared minus 7, what could f of x and g of x have been? Give it a try. Write it on your paper. Act like this is a test question. I'm going to have you show somebody else, and I want to get an honest opinion of whether you would have had it right or not. This would be like an R2 level question. These are pretty easy. In a second, I'm going to have you show somebody else and see if you might have different than them, but see if your way works. Have them look at it for a second and see if theirs isn't the same, whether they can make it work or not. Okay, go ahead, show somebody else. See if yours is similar to theirs, same exact, or if yours way works too. Okay, now if you want to know if your way really was right, you probably already know if you and your partner talked it over thoroughly, but if not, here's the way you do it. I would figure out g of x, and I would have pulled out the whole thing personally, but you can do it either way. If I pull out the whole thing and say g of x is x squared minus 7, then I just replace that with an x, and I say f of x must be everything else, square root of x. Raise your hand if you did it that way. All right, and then here's another way. You could have just pulled out the x squared and pulled out just this part, and then I would say the remainder is x minus 7. Raise your hand if you did it that way. Either way works. Neither way is better than the other. They both. Okay, so that's called decomposition. So your homework for today is a page of those, and that part's really easy. Like seriously, you'll finish that in 8 minutes. And then the rest of it is review of yesterday's stuff. And I felt like the worksheet was a little bit long, so I did have you skip one of those. But I think I'm going to do one problem on the video because the video is kind of short today. So I'm just going to do one of your homework problems together with you and leave it on the video here. So here's your worksheets. 3, 4, 5. Okay, number 5 is the first one on that sheet. It says square root of x squared minus 5x. And that is f of g of x. That's what that is. And they want to know what would f of x and g of x. Give it a shot. I think most of you get it right. Without half your cerebellum tied behind your oblongata or whatever it's called. Let's try and name it a couple of brain parts there. A little difficult. All right. I think I would probably have pulled out this whole thing and said that g of x is that, and then I would have said f of x is the other part, square root of x. Now, can anybody think of a cheat way you could do these? I knew you'd think of it. Go ahead. Okay, hold on. Let me just show you what I know what he's going to say, but I want you guys to see this. So, all right. So, what would you say f of x? Oh wait, no. Say what g of x is first. That's the whole original problem. And then, okay, we don't allow that. It works. I know. I knew you would say that. Why? It works. Should be right. Because you could do that with anything. You can take the whole function out and replace it with an x. But it's right. Yeah, we're going to have this argument in the test, I can tell. No, I'm not going to accept it. Just deal with that. You can't do that. You can't take the whole thing out. You got to pick something to take out that's not the whole thing. All right, so you can take out maybe that part, and then you can leave it something. You can't just have f of x equals x. You have to have something more than that. So that's a kind of a cheat way. It's right, kind of, but we won't accept it. Yes? Good question. You do not have to list all the possibilities. Just one is fine. No. No. Because you're right. You can do backwards too. All right. So there's a start, at least on the decomp part. And that's all we have for the video. No. Okay. Actually, I'm going to add one more thing to my video. There's another sheet to the worksheet that has a part about finding common denominators that can be kind of hard. So everybody do number 1 with me on the other worksheet now. Number 1 says that f of x, it's recording again, is 1 over x minus 7, and the other function is x plus 4. G of x is x plus 4. So now, if I'm going to put the adding part, believe it or not, is kind of a hard part. F plus g. Here's how I do it. I have to add this 1 over x minus 7 to that, plus x plus 4. That doesn't seem that hard, but the problem is you can't add things that are fractions unless they have a common denominator. So I got to get you guys good at a few basics here, like adding things that don't have a common denominator. So I'm going to put this over 1. Do you remember that when you find common denominators that you generally just have to multiply your two denominators together to find out what the common denominator should be? Like if you were going to add 1/5 plus 3/7, you do 5 times 7 is 35 would be a good common denominator. Get you multiply these. Same idea. What would be a good denominator here? Just multiply that times that. So my denominator is x minus 7. Well, this one's already got x minus 7 as a denominator, so I need to make that one have an x minus 7 for a denominator. So if I'm going to do that, I times it by x minus 7 down here, and if I do it there, I got to do it right up above it. On the same one, I have to do x minus 7 there. Why is that? Because this whole thing is equal to 1. And that's what makes it okay to just do that. You can't just multiply things by x minus 7 if you feel like it, but you can multiply things by 1. All right, so now that I did that, I can actually add them. I want to help you understand this. When you add them together, your denominator stays the same. So my final answer has an x minus 7 as the denominator. Yet you don't add these? Like if I had 1/5 plus 2/5, don't you get that I would not add the 5s and call it tenths? I would add the tops and say 3, and I'd leave the denominator the same. Get what I mean? This 5 does not change. So my denominator is just x minus 7. The top I do need to add. What's 1 plus all that junk? Well, that junk needs to get multiplied. So right in there, I have a little FOIL problem. X squared minus 7 and plus 4 makes minus 3x. And then minus 28, and then don't forget the 1. Another 1, plus 1. And then I can actually add the negative 28 and the plus 1 together and get my final answer, which would be x squared minus 3x minus 27 all over x minus 7. That's the grinded out part that it seems like it's super easy to just add the functions, but sometimes the functions will be not common denominators. All right, that is going to be something you have to know for tests. So you need to learn how to do common denominators like that. So don't skip over that part. Ask me if you get stuck on that part. Now, when we change this to a minus for the subtract one, can you use the same denominators? Yep. No reason to rewrite this whole thing. I mean, you've already got it changed to common denominators. But when you do the f minus g, you're just going to subtract. So all of these things here that we had from this side, if I'm subtracting them, I just have to put a negative in front of all of that. You know what I'm saying? It's going to be pretty much the same thing when I change to f minus g, except there'll be a minus here. So it'll be a negative in front of all that stuff. All right, but I don't want to change it. I want to leave this the one example. All right, so that's adding them. And then what about the domain? Well, that's pretty easy. These is just an add one, so you just take the two parent domains and overlap them. One of the domains is all reals, and the other one is x can't be 7. So I make my two little number lines. Personally, it's what I would do. All reals. How long does that take to make? Very easy. But not 7. Empty spot at the 7. And when they overlap, anything with all reals is just the other thing. So it's all reals except x cannot be 7. All right, so there's your domain, and there's your answer to it. Or there's the function, I should say. There's the function, there's the domain for it.